Standard Instrument Approach Procedures, or IAPs, allow you to safely descend by instrument reference from the en route structure to a point near the runway where a landing may be made visually. All instrument approach procedures in the United States are based on U.S. terminal procedures, commonly referred to as TERPs. TERPs outlines the criteria used to develop instrument approach procedures. Approach charts are the visual form of an instrument procedure and give you the vertical and horizontal information necessary to make a successful approach to an airport. In this segment, we'll look at what information is contained on an approach chart and how it is presented. Then we'll look at some new technology that is appearing on your approach charts. Before beginning, it should be noted that Jeppesen does not create the criteria or devise the procedures for an approach. This is done by the governing authority in each country. In the United States, this authority is the Federal Aviation Administration, or FAA. You should also know that charts are frequently updated, ensuring you have the most current and up-to-date information. Some years ago, Jeppesen introduced a new chart format. It was tested and evaluated by human factors professionals, airline crews, and general aviation pilots. The new chart format is known as the Jeppesen briefing strip format. While not every chart in the Jeppesen Approach Chart Library has been converted to the briefing strip format, the vast majority of charts have been redone. This program concentrates on the briefing strip format. However, it also contains a brief review of the classic Jeppesen chart style. The briefing strip approach chart format is divided into 4 sections: heading, plan view, profile view, and landing minimums. The information is arranged in a specific pattern based on how pilots review and use the chart data. Let's take a closer look at the heading portion of the chart. The information on the chart flows from right to left. On the top right side, you will find the location of the airport by city and state. All Jeppesen civil approach charts are filed alphabetically by city name within the state. The city name is shown in bold print for easy recognition. The specific procedure is noted below the city name. The name of the procedure identifies the type of approach and the primary navigation aid upon which the approach is based. It does not indicate the equipment required to fly the entire approach. It merely indicates the equipment needed to fly the final approach segment. If NDB is listed as a part of the procedure, such as it is here, NDB equipment in operating condition is required to be installed in your aircraft in order to fly the final approach segment. In the case of a VOR DME approach, you would need VOR and DME equipment. However, if the approach is titled VOR DME or GPS, either VOR DME or GPS equipment can be used to fly the approach. Both are not required. If the approach course is not aligned within 30 degrees of the runway, the approach is identified with a letter. Notice that this approach is called the VOR DME or GPS A approach. A circle to land maneuver is required to align the aircraft with the runway. The series of numbers in the center of the chart is the index number. It helps you file the chart and identify certain features. The first digit identifies the airport within a city based on an arbitrary number assigned to each airport. The second digit represents the type of approach chart and is based on the navigational aid used to conduct the approach. In this example, the number 1 represents an ILS, MLS, LOC, or SDF approach. Typically, approaches with the lowest landing minimums and greatest precision have a lower index number than approaches with higher minimums. The chart legend lists the assigned numbers for each type of chart. The third digit represents the filing order of charts that are of the same navigational type. The number 1 shown here indicates this is the first ILS approach chart for DFW. The next ILS approach chart for the same airport would be listed as number 2. The revision and effective dates are also found in the center of the chart heading. Never use a chart before the effective date. If there is no effective date, the chart is for use upon receipt. On the far left side of the chart is the four-letter ICAO identifier for the specific airport. In this case, KDFW is the ICAO identifier for Dallas-Fort Worth International Airport. The next few rows of the heading section contain information about the approach. This includes communications, pre-approach briefing information, and MSA information. From left to right, the communications section provides the frequencies in order of arrival, such as ATIS arrival, approach, tower, and ground control frequencies. Multiple frequencies may be given for a particular facility, such as the tower frequency here at DFW. In this case, the frequency depends upon whether your arrival is from the east or the west. Also be aware of any notes or symbols in the communications row. For example, the Redbird Tower and ground frequencies do not operate continuously, as noted by the asterisk. In addition, when the tower is not in operation, you are advised to use the Common Traffic Advisory Frequency, or CTAF. In this case, the CTAF frequency is the same as the tower frequency. In select locations where a flight service station, or FSS, is located on the field and can provide local airport advisories, this information is noted on the chart as it is here in Jackson, Tennessee. The second row of boxed information is designed to provide you with a quick reference of the pertinent approach-related information. From left to right, you see the primary nav aid and its frequency and identifier. At DFW, the localizer is the primary nav aid. Its identifier is ILWN, and the frequency is 109.5. Next is the final approach course. In this case, the final approach course for the ILS runway 13 right at DFW is 133. Next is the key altitude information. For a precision approach, this is the glide slope outer marker altitude. For example, the glide slope altitude at Good, the outer marker, is 2,235 feet MSL. For a non-precision approach, it is the minimum altitude at the final approach fix. Following the glide slope information is the lowest decision altitude, DA, or minimum descent altitude, MDA, depending on the approach type. The ILS decision altitude is 791 feet. Also included in the pre-approach briefing information is the airport elevation and the touchdown zone elevation. Below this row of information is a textual description of the missed approach procedure. On this particular approach, the procedure requires a climb to 1,000 feet, then a climbing right turn to 5,000 feet outbound via the TTT or Maverick VOR on the 275-degree radial to the slot intersection. Slot intersection is 35.6 DME from Maverick. Any notes that are applicable to the approach, such as altimeter setting or equipment requirements, are included below the missed approach information. In this case, radar is required for this approach. The minimum safe altitude, or MSA, is located to the right of the pre-approach briefing information. The altitude shown in each sector provides a minimum of 1,000 feet of obstacle clearance within a 25 nautical mile radius of the navigation facility. The name of the facility is listed below the circle. MSA altitudes are intended only as emergency information. Normally, the MSA is based on the primary nav aid on which the IAP is based. For RNAV and GPS approaches, however, the MSA is based on the runway waypoint, airport waypoint, or the missed approach waypoint. It is important to note, however, that if the primary navigation facility for the approach does not provide full azimuth reference information, such as an ILS, the minimum safe altitude is based on the primary omnidirectional facility in the area. The MSA circle may be broken into individual sectors of no less than 90 degrees each. Notice that the sectors are formed by magnetic bearings to the station. In this example, the north sector is formed between the 090 and 270 degree bearings to the Maverick VOR. The second major section of the approach chart is the plan view. This view provides you with the overhead perspective of the approach procedure and the surrounding airport vicinity. To help you measure distance, a mileage scale is located along the left side of the chart plan view. Typically, 1 inch is equal to 5 miles, but it may differ if the chart covers a large geographical area. Latitude and longitude lines are shown in 10-minute increments along the inside edges of the plan view. The primary airport is depicted with its corresponding runway layout. For reference, airports in the vicinity that have an instrument approach, or VFR airports that underlie the final approach, are shown with light shading. A star symbol indicates the airport has a lighted beacon. Several types of orientation details are also shown on the plan view of approach charts. These include ground features like major lakes or rivers, as well as terrain high points and man-made structures. Typically, only those points and structures higher than 400 feet above the airport elevation are depicted on the plan view. Remember, not all man-made structures or terrain high points are depicted on the approach chart. Various symbols are used to represent terrain high points and man-made structures. These symbols are defined in the chart legend. A bold arrow is used to point out the highest known terrain or structure. The mean sea level elevation is given next to the symbol. It's important to know that there may be other higher uncharted terrain or man-made structures. The terrain and obstruction altitudes depicted on the chart should not be relied on for descent below the minimum IFR altitudes. Terrain contour information is depicted when terrain within the approach chart plan view exceeds 4,000 feet above the airport elevation, or when terrain within 6 nautical miles of the airport reference point rises to at least 2,000 feet above the airport elevation. This information is for reference only and must not be relied on for terrain clearance. Minimum IFR altitudes published on the procedure provide terrain clearance. Nav-aid symbols shown on the plan view are similar to those found on other Jeppesen charts. For example, a VOR is indicated by a compass rose. A TACAN or DME is symbolized by a serrated circle, and a VORTAC or VOR DME is represented by combining the two symbols. Localizer, ILS, LDA, SDF, and MLS course approaches are shown as a half-feathered arrow. The primary navigational aid information is shown in bold type enclosed in a shadowed box. The information boxes for other facilities depicted in the plan view are not shadowed. Each information box contains the facility name, frequency, letter identifier, and Morse code identifier. If a D appears in the box, it indicates the facility transmits DME information. The letter H, in parentheses, indicates this is a high-altitude VOR station. If the letter T appears, the station is a terminal-class facility. An L indicates a low-altitude class VOR. If the facility is a localizer, ILS, LDA, SDF, or MLS, the nav-aid information is enclosed in an oval-shaped box. On localizer back course approaches, the front course information is also included in the box. This is provided for pilots flying aircraft equipped with an HSI. Various approach transitions are also depicted on the chart to assist you during the transition from the en route structure to the initial approach fix, or IAF, especially when the IAF is not part of the en route structure. Approach transitions are flyable routes that provide a minimum of 1,000 feet of obstacle clearance. This obstacle clearance extends 4 nautical miles on either side of the charted course. You can determine if a line on a chart indicates a flyable route or is simply a radial or bearing forming a fix by noting several items. The magnetic course is shown with the course line, and the nautical mile distance is printed next to the line. The route also has a minimum altitude, such as 4,000 feet. In addition, a flyable route uses a wider, darker line than the one used to indicate a radial or bearing forming a fix. Notice the difference between the two lines that point to Pipes intersection and the line between Pipes and Argan. The lines locating Pipes intersection are simply radials from a VOR that help locate the beginning of the DME arc and the initial approach fix. They are not flyable routes. On some routes, you must fly a heading rather than receive course guidance from a navigation facility. For routes in which this occurs, the letters HDG are printed near the route. Initial approach fixes are indicated on the plan view with the notation IAF. In this example, there are 3 initial approach fixes, one at caps, one at pipes, and one at R059, which is the 059 degree radial 14 DME from the Gregg County VOR. An initial approach segment is shown extending from each of these IAFs. If a course reversal is authorized, it is depicted on the plan view. When this type of symbol is used, you may reverse course any way you desire as long as you stay on the same side of the radial as depicted on the chart, which allows you to remain within the protected airspace. You must also stay at or above the minimum altitudes and within the distances shown on the profile view. When a procedural track is charted, as shown here, or depicted as a holding pattern like this, you must fly the procedure exactly as shown unless you are being radar vectored to the approach course. When the notation "No PT" appears, a procedure turn is not required or authorized. The next segment of an approach is the intermediate segment. It may begin at an intermediate fix, IF, or when you are aligned with the final approach course after flying the DME arc or the procedure turn and ends at the final approach fix. While flying the intermediate segment, you have a minimum of 500 feet of obstacle clearance. The width of this segment tapers from 4 nautical miles on either side of the course at the start of the segment, down to as little as 2 nautical miles at the final approach fix. The final approach segment begins at the final approach fix. On a precision approach, this is the point where you intercept the glide slope at the minimum glide slope intercept altitude. This interception usually occurs near the outer marker, which in this case is good. The final approach segment ends at the runway or at the missed approach point, whichever is encountered last. The missed approach course is indicated by a dashed line on the plan view. When information concerning the missed approach continues off the plan view, an inset is provided. The inset area is not drawn to scale. Now let's discuss the profile view of Jeppesen approach charts. The profile section of the chart is a side view of the procedure, but unlike the plan view, is not drawn to scale. This view depicts the altitudes, fixes, distances, and magnetic courses to be flown. The dominant feature of the profile section is the heavy solid line representing the flight path. Before glide slope interception, this line represents the flight path for both the precision ILS and non-precision localizer approach. Beyond the glide slope interception point, the solid line represents the ILS approach. The localizer approach path is depicted by a dashed line. On a non-precision approach, such as this VOR approach at Dallas-Fort Worth, the flight path is represented by a heavy solid line from the beginning of the approach to the missed approach point. Several altitude types also may be portrayed in conjunction with the flight path line. Unless otherwise noted, profile views depict minimum altitudes. However, an altitude may be listed as mandatory, which means you must cross the specified fix at the given altitude. Altitudes may also be depicted as maximum altitudes. If the approach requires a course reversal, it is depicted in the profile view along with the altitudes and outbound and inbound course. Additional information about the course reversal is noted in the plan view. The number enclosed in parentheses below or beside the MSL figure indicates the height of the flight path above the runway touchdown zone, not the height above the ground. In this example, you are 1,646 feet above the runway touchdown zone. There may be a notation shown in the profile view, such as 10 nautical miles. Notes such as these indicate that a procedure turn is required for the approach, and they give procedure turn limits in distance or time. In this case, you must complete the procedure turn within 10 nautical miles of the fix from which the outbound track began. On this approach, the 2 facing arrows indicate you must use a holding pattern as your course reversal. You can find the direction of turns on the plan view. 1-minute legs are specified for this holding pattern, and both legs are flown at 2,400 feet. The final approach fix, or FAF, marks the beginning of the final approach segment on an ILS approach. The FAF is located at the glide slope intercept point when at the minimum altitude. For this approach, the final approach fix is just prior to reaching Good, where the solid line begins a descent. The notation GS 2235 represents your altitude as you pass Good when on the glide slope. For the localizer, glide slope out, or non-precision approach, the FAF is identified by the cross symbol. For example, you cannot begin your descent from 2,300 feet until you reach the non-precision final approach fix at Good. For a localizer-only approach, the dashed flight path indicates a descent from Good to the missed approach point, or MAP, as identified by the letter M. Notice that this non-precision localizer-only approach includes various step-down fixes, such as a DME distance fix like D3.4, which are used to help you descend to a lower altitude and avoid obstacles along the approach path. The flight track continues to the point at which it turns sharply upward, ending with an arrowhead. This shows the beginning of the missed approach procedure. The missed approach point for a precision approach is based on reaching the decision altitude, DA. It is typically shown close to the middle marker where the solid line indicates climbing flight. When you reach the DA, you must make an immediate decision to continue or to execute a missed approach. The threshold crossing height, or TCH, is listed to show the height above the runway threshold where your aircraft's glide slope antenna will be if you maintain the ILS glide path to touchdown. A threshold crossing height is not shown on non-precision approaches. The touchdown zone elevation, or TDZE, is shown next to the runway symbol. This is the highest elevation in the first 3,000 feet of the landing surface. It may be different than the airport elevation, which is the highest point of an airport's usable runways. Two sets of numbers, indicating distances expressed in nautical miles, may be located near the bottom of the profile view. The numbers below the line relate to the distance from the landing threshold. Those numbers above the line represent nautical mileage between fixes. In this case, the distance between Ipamee and Uhizo is 5 nautical miles. Now let's take a look at a few variations that may appear in the profile view of an approach chart. It is important to look at some of these differences. However, keep in mind that additional information can be found in the chart legend pages. The circled number refers you to a note located elsewhere in the profile view. This note indicates that when authorized by air traffic control, you can fly at a lower altitude of 2,300 feet when crossing Maury and Papa. This is in lieu of the 3,000-foot altitude listed on the chart. Some non-precision approaches incorporate a visual descent point, or VDP. It is represented by the symbol V on the profile view. It is the location where you may begin a normal descent from the MDA if you have the runway threshold, approach lights, or other identifiable markings of the runway environment in sight. If VASI lights are installed at the airport, your aircraft should be on the VASI glide path at the visual descent point. This VDP is identified by the D4.7 DME fix. This point is an advisory fix, as noted by the thin vertical line. Now let's turn our attention to the conversion table located below the profile view. For a precision approach, the conversion table relates the aircraft's ground speed to the rate of descent necessary to maintain the glide slope. For example, the table shows that at ground speed of 120 knots, your descent rate needs to be approximately 647 feet per minute to stay on the glide slope. In this case, the glide slope is based on a 3-degree descent angle. Depending on the type of approach you're flying, different information may be included in the conversion chart. For non-precision approaches, the bottom line of the conversion chart usually includes the elapsed time from the final approach fix to the missed approach point. It applies only to non-precision approaches because the MAP location for the non-precision approach is usually at the runway threshold and the approach can be timed. Whereas the MAP for an approach using glide slope information occurs approximately 1/2 mile from the threshold when you reach the decision altitude while on the glide slope. When the conversion table is blank, the missed approach point is not based on elapsed time or ground speed, but rather is a specific point. The MAP in this example occurs at the NDB, which is located on the airport. To the right of the conversion table is the lighting box. The lighting box displays a symbol that represents the type of lighting installed for a straight-in landing runway. The symbols for each type of lighting are listed in the chart legend. When ALS is listed, the configuration of lighting is unknown. Also note, when PAPI or VASI are depicted in the lighting box, it is shown either on the left or right side of the runway. This corresponds with the side of the runway on which the lighting system is actually installed. When the lighting box is blank or omitted, the runway has no approach lighting. The missed approach information is found next to the lighting box. Here, icons offer a quick graphic depiction of the textual missed approach procedure. In this case, 4 icons are used. First, climb to 1,000 feet. Then make a climbing right turn to 5,000 feet outbound via the Maverick VOR on the 275-degree radial until you get to slot intersection. This should match the textual description of the procedure. The approach chart legend in the front of the airway manual explains other icons that may be used to depict the missed approach procedure. Because each missed approach is unique, read the procedure carefully and compare it to the missed approach track portrayed in the plan view to make sure you fully understand the procedure. When a missed approach procedure calls for a turn, it's important to understand that the obstruction clearance criteria are figured from the missed approach point. Do not begin a turn until you have reached the missed approach point. The last major portion of this chart is the landing minimum section, which outlines the minimum altitude you can descend to on the approach and the minimum visibility required for the approach. Landing minimums usually increase when a required component or visual aid becomes inoperative. Jeppesen charts present this information in a logical sequence. For instance, the lowest minimums for the approach are located on the left side of the box. As you move to the right, the minimums increase. On most approach charts, the minimums table represents 2 groups, straight-in approaches and circle-to-land approaches. On ILS approach charts, the straight-in landing section is further divided into minimums with and minimums without the glide slope. On the left side of the minimums box, aircraft categories are represented by the letters A, B, C, and D. The minimums depend upon the category of aircraft you are flying. The FAA has established 5 approach categories based on an aircraft's approach speed. For the most part, the last category, Category E, is not shown on approach charts since it applies only to military aircraft. The approach speed of a particular aircraft is computed as 1.3 times the stalling speed in the landing configuration at maximum landing weight. Most single-engine general aviation aircraft fall into Category A. The first column of an ILS approach is designated as full. The minimums within this column apply when all components are operational. In this example, no matter what category of aircraft you are flying, you can descend to a decision altitude of 791 feet MSL, which is 200 feet above the touchdown zone elevation. Notice that these figures are labeled DA parentheses H. The DA, or decision altitude, is the MSL altitude at which you must make your decision to execute a missed approach or to continue the approach. The DH, or decision height, is shown in feet AGL within the parentheses. For the full ILS, you also must have a touchdown runway visual range of 1,800 feet, or if RVR is not reported, a visibility of 1/2 statute mile. As you move to the right, you can see how the visibility requirements change for various inoperative lights. If more than one component is inoperative, you must use the more restrictive minimum. For example, if both the runway alignment indicator light system and the approach light system are out, use the minimums listed in the rail or ALS out column. For the localizer, glide slope out, or non-precision approach, the figures are labeled MDA parentheses H. The MDA, or minimum descent altitude, is the MSL altitude below which descent may not be made without visual reference. The H, or height, above touchdown is shown within the parentheses. Sometimes sidestep landing minimums also will be published. Typically, these minimums are higher than for the straight-in runway. This allows you to fly an approach to one runway and then land on a parallel runway. On the far right of the chart are the circle to land minimum altitudes, heights, and visibilities. Remember, not all approaches offer circle to land minimums. The protected airspace during a circle to land maneuver depends on your aircraft's approach category. The airspace ranges from 1.3 nautical miles from the runway end for Category A aircraft to 2.3 nautical miles for Category D aircraft. Remember, if you're flying the maneuver at an indicated airspeed that's faster than the maximum limit of the speed range for your category of aircraft, you must use the higher minimums. Otherwise, you might not have the necessary obstacle clearance. The altitudes in parentheses show heights above the airport. These numbers are not based on heights above the touchdown zone because circling minimums are not referenced to a specific runway. A note on this chart indicates that circling approaches are not authorized east of runway 16 left and 34 right. While there are many reasons for a note of this type to be published, one reason may be obstructions within the circling approach area. Again, it's important to look at some variations within the minimums box. On this approach, there is a decision altitude and height penalty when using a remote altimeter setting. This example shows an approach that doesn't have straight-in landing minimums. Remember, straight-in landing minimums are omitted when the final approach is not aligned within 30 degrees of the runway, or if an excessive rate of descent, generally over 400 feet per nautical mile, would be required between the final approach fix and the missed approach point. On the other hand, you are not prohibited from landing straight in when an approach does not show straight-in landing minimums, provided that you break out in time to position the aircraft and make a normal final descent to the runway. Notice that there are different minimums for this approach depending on whether or not you can identify a specific DME fix. Since it is a step-down fix, once you have identified it and crossed it, you can descend to the lower minimum altitude. As you begin to investigate the different types of approaches, you may encounter Category 2 and 3 approaches. Category 2 and Category 3 ILS approaches use the same basic format as a standardized ILS. However, you must be a Cat 2 or Cat 3 authorized pilot and have a Cat 2 or 3 equipped aircraft to use the approaches. Typically, they have lower approach minimums than a standard ILS and may list multiple decision altitudes based on operator requirements and equipment. For example, a Cat 2 decision altitude is normally 100 feet above the touchdown zone elevation. As a pilot, it is prudent to thoroughly read and understand the profile view of the chart. If there is something noted on the chart that you haven't seen before, refer to the chart legend and the Jeppesen Chart User's Guide for further information. Finally, if any changes were made to the chart during the last revision cycle, they will be noted along the bottom edge of the chart. In this example, the MSA altitude was changed. The information we've covered so far is primarily aimed at traditional approaches, such as ILS, localizer, VOR, and NDB approaches. But the world of aviation navigation is changing rapidly, and so are approach charts. This next segment is designed to explain the changing technology and terminology that you'll see on Jeppesen approach charts. With the widespread deployment of area navigation systems and the advent of satellite-based navigation, greater flexibility in defining routes, procedures, and airspace is now possible. To capitalize on the potential of these new technologies, the FAA, in conjunction with the International Civil Aviation Organization, ICAO, has introduced a new standard of navigation and airspace management called Required Navigation Performance, or RNP. The theory behind RNP is to establish one performance standard that applies to aircraft, airspace, pilots, air traffic controllers, and international aviation authorities. This single performance standard is enabling the widespread use of area navigation, or RNAV. The term RNAV no longer refers solely to the VOR station mover of the past, but rather encompasses several different types of navigation equipment. The heading RNAV applies to GPS, INS, VOR-DME, and LORAN-based navigation systems. When a specific RNP standard is given, such as the ability to maintain a course of 1 nautical mile on either side of a course line, it doesn't matter how the RNAV system calculates position, as long as it provides navigation that meets the specified required performance. A given RNP level is applicable to a specific route, airspace, or procedure. The RNP value is expressed as a distance in nautical miles. Currently, in the United States, there are 3 RNP levels: 0.3, 1.0, and 2.0, but additional RNP levels will be added. RNP 0.3 represents a distance of 0.3 nautical miles, or 3/10 of a nautical mile, on either side of a specified center line. At the present time, a 0.3 RNP level is the highest level. An example of this RNP level is the specific performance required on the final approach segment of an instrument approach. An RNP level of 1.0 is typical of that used to define a terminal route. And an RNP level of 2.0 is the width typically used for en route operations. You need to have a clear understanding of the aircraft requirements for operation in a given RNP environment, and advise ATC if an equipment failure or other malfunction would hinder your operating ability within the designated RNP airspace. When appropriate, the applicable RNP level will be depicted on IFR charts. For example, the Baltimore, Maryland RNAV GPS runway 10 approach chart includes a notation GPS or RNP 0.3 required. Aircraft that meet RNP criteria have an appropriate entry in the aircraft flight manual or its approved supplement, including any conditions or limitations. The implementation of a worldwide RNP standard marks the beginning of a fundamental change in air navigation. The FAA, in cooperation with the aviation industry, is designing an entirely new system of navigation to take advantage of these changes. The next generation of air navigation will be a satellite-based system. It will be known as the GNSS Landing System, or GLS. GNSS stands for Global Navigation Satellite System. The major component of this system is the GPS satellite system currently in use. GPS signals will be augmented by ground-based stations known as WAAS, or Wide Area Augmentation Systems, and LAS, or Local Area Augmentation Systems. GLS will allow GPS to be used for non-precision approaches as well as Category 1, 2, and 3 precision approaches. GPS and other area navigation systems are becoming more commonplace as new electronic navigation equipment is being developed and installed in commercial as well as general aviation aircraft. In order to support the full integration of area navigation into the National Airspace System, the FAA has developed a new charting format for all RNAV instrument approach procedures. This format incorporates all types of approaches that use area navigation systems, including ground-based, satellite-based, and other approach-approved systems. The goal of the new RNAV charts is to avoid the unnecessary duplication of charts. All GPS approaches, both unaugmented, today's GPS, and augmented, WAAS and LAS when operational, are published using the same new chart format. The approach is titled RNAV, GPS, and the runway number. The Tallulah-Vicksburg GPS runway 18 is now the RNAV, GPS runway 18. Also, when multiple RNAV approaches to the same airport runway exist, the procedure name includes a letter code beginning with the end of the alphabet. The Baltimore-Washington International Airport has the RNAV GPS Zulu runway 15 right, and the RNAV GPS Yankee runway 15 right approaches. One of the approaches contains LNAV, VNAV, lateral and vertical navigation minimums, while the other approach includes LNAV, lateral navigation minimums only. Another change in the heading section is the way decision altitudes are portrayed. The lowest decision altitude or minimum descent altitude is still given. However, it is referred to as the LNAV VNAV DA parentheses H or the LNAV MDA parentheses H. New notes will also show up on RNAV charts in the heading portion of the chart. You may see requirements for the approach, such as radar required, GPS or RNP 0.3 required, DME RNP 0.3 not authorized, and Baro VNAV not authorized below minus 15 degrees Celsius. Some RNAV systems utilize barometric pressure readings to generate a computer-guided vertical navigation path. This is called Baro VNAV, and in this case, it is not authorized for use below minus 15 degrees Celsius. Some systems calculate lateral positions based on DME readings. If your system operates by DME triangulation, you are unable to use the LNAV VNAV minimums for the Yankee Runway 15 right approach. Since every system operates in a different manner, you must have a thorough understanding of the operational capabilities of your GPS or FMS system in order to comply with these requirements. The MSA on RNAV charts also contains an important difference. The MSA is predicated on a waypoint, such as the missed approach waypoint, instead of a navigational facility. However, the MSA does not exist on all RNAV charts. Rather, a terminal arrival area, or TAA, is incorporated into the approach and acts as an MSA. A TAA provides an efficient method for aircraft to transition from the en route structure to the terminal area for an RNAV approach. TAAs are charted on the plan view to represent one of three arrival areas: left base, right base, and straight-in arrivals. The TAA also provides multiple initial approach fixes as well as an intermediate fix for the approach and are designed to reduce the need for procedure turns. Flyover and flyby waypoints are also in the plan view. A flyover waypoint is depicted by a four-pointed star with a circle around it. This type of waypoint is typically used for a missed approach point or missed approach holding point when it represents a specific point in space that must be flown over. A flyby waypoint is typically a position in which a change in the course or procedure takes place. It is represented by a four-pointed star. You can anticipate and begin your turn prior to reaching the waypoint, resulting in smoother transitions. Now let's take a look at the different things you may encounter in the profile view of an RNAV chart. To further enhance aircraft operations using RNAV approaches, vertical navigation information is published in the profile view. This symbology represents vertical descent information that is coded into the navigation database. It provides guidance to allow for stabilized, constant rate descents on selected non-precision approaches. The VNAV information in the profile view illustrates the geometric descent path and descent angle from the final approach fix to the threshold crossing height at the approach end of the runway. The descent angle appears in brackets along with the descent path. Notice the descent path is a screened dotted line. The descent angle and ground speed information can also be found in the conversion table on the chart. The TCH, or the height at which the descent angle crosses the runway threshold, is also depicted in conjunction with the descent angle. The actual height in feet is stated over the end of the runway. The inclusion of VNAV descent angles does not preclude the use of minimum descent altitudes or missed approach points. You cannot descend below the MDA unless the required visual cues are present. One very important change to the profile view is the appearance of notes on some non-precision approaches. In the profile view of this VOR DME approach, you see a ball flag and a note stating, "Only authorized operators may use VNAV DAH in lieu of MDAH." This tells you that the DAH operational techniques apply to operators who have obtained permission from their controlling authority. Use of the DAH operational technique is subject to appropriate flight crew training, proper equipment, and operator approval. Contact your local FSDO for more information regarding the authorized use of VNAV decision altitudes. Also new to the profile view of selected Jeppesen RNAV approach charts is the addition of a figure that denotes the distances from the last fix to the decision altitude and the decision altitude to the missed approach point. On this chart, the distance from the last fix to the decision altitude is 0.8 nautical miles, and it is 1.1 nautical miles from the decision altitude to the missed approach point. The last major difference you will find on RNAV charts is a new descent minimum format and new terminology. The new RNAV chart format may include as many as 3 approach minima: LNAV, VNAV, LNAV, and circling. LNAV VNAV identifies minimums developed to accommodate a non-precision RNAV instrument approach with lateral and vertical guidance. Aircraft capable of using LNAV VNAV minimums will make their final descent using a descent path generated by onboard navigation equipment. Since vertical guidance is provided, the minimums will be published and flown as a decision altitude, even though it has higher non-precision approach minimums. When determining your ability to use the DA for LNAV VNAV minimums, you must take into account the notes listed above the plan view on the charts that were previously discussed. LNAV minimums are designed for non-precision approaches that only provide lateral navigation. Because vertical guidance is not provided, the minimums will be published as an MDA. RNAV approaches and procedures are rapidly increasing in number. As this new technology becomes more commonplace among pilots, it is important to remember the burden rests on the pilot when determining the ability to use RNAV procedures. Information is continually added to FAR and AIM publications in order to expand the use of RNAV. Contact your local FSDO if you have any questions regarding the use of your navigation system for RNAV operations.